FedEx Ground, an independent operating company within the FedEx Corporation, is a small package delivery service throughout the United States and Canada. Within FedEx Ground, there are several operating areas that each complete a crucial area of the business. Some of these include first and last mile engineering, hub and outbound sortation, and line haul, just to name a few. Our project focused on the line haul operating area. Line haul is responsible for the movement of packages between sortation facilities throughout the FedEx network. To move the millions of packages needed daily, Linehaul uses three main approaches: independent contractors within FedEx, outside contracted services, and railways. The current process for planning railway routes is excessively manual and information is scattered across several different sources. Our team was challenged with designing and developing a user-friendly, adaptable information system that can be used by a wider set of planners and effectively utilize user input to plan for future routes. To accomplish this, it was absolutely vital to have a simple user interface where only key parameters would be taken into the system, as well as internalize all necessary date and time calculations. Some other crucial factors the team considered were ease of data updates and multiple users able to use the tool simultaneously. To meet all of the project requirements, our team decided to use a form through Microsoft Excel and Visual Basic to read in necessary route parameters. Additionally, we designed multiple R codes to perform the necessary error checking and date time calculations when planning possible rail routes. These codes will be executed through a computer's command prompt so that a user does not need to know any specifics in executing codes through R. Our Visual Basic form takes in only the vital information from the user that needs to be specified to plan a route. These fields include the origin station, destination station, departure date, due date, time due, and container type. All other parameters are either calculated or assumptions that are built into the model. For the origin and destination station, the user can either enter a 3-digit station ID or a 4-letter station abbreviation. After hitting the submit button on the form, our Visual Basic code will send the information to an Excel sheet, which is then read into our R scripts. Once the information is entered, the information will be error checked through an R script to ensure that the station information exists within the data, as well as that the dates are feasible dates. Calculating the feasible routes starts by reading in relevant information about each FedEx Ground facility, associations between FedEx facilities and rail yards, possible rail yards where crosstowns can occur, and the rail schedule. All of these files stay in the current format that FedEx Ground is familiar with so that updates can be easily made, and all that is required is for the newest files to be reread into the code. Using the user-entered information, the code first checks to see if there are any feasible routes between origin and destination by finding the nearest rail yards to each and checking for matches in the rail schedule. After checking if a direct route exists, we next check to see if a crosstown route exists. A crosstown route is when a container or trailer starts at a rail yard near the origin station, is transported to a rail yard at another location, taken off of one company's tracks, and moved to a separate new rail yard. This typically occurs within the same city. After arriving at the new rail yard within the city, the container is put back onto the rail tracks and moved to a rail yard near its final destination station. Crosstown routes are much more complex as they require 2 rail trips and transportation between 2 rail yards in the middle of the overall trip. Additionally, each rail trip has an associated cutoff time in which if the trailer or container is not there, it will not meet service. Thus, it is vital to have accurate time calculations and buffers in the model to ensure service can be met. Our model searches for both possible direct routes and crosstown routes every time it is run to ensure that all options are presented for the employee using the rail planning tool. Both of these outputs are combined into one final summary table. The final summary table is ultimately written to an Excel file. This ensures that the user does not need to see any of the R code to perform the rail planning process. The writing of one final summary table to Excel ends the coding and analysis done by our program. To perform another analysis, the user can simply input new parameters and rerun the codes to produce a new summary table. Overall, our tool allows FedEx Ground to simplify their process for planning rail routes and expand the number of people capable of completing this task. Furthermore, The tool allows for easy data updates, flexible parameter entry, and multiple users at once. This tool will enable FedEx Ground to be more effective in their rail planning process.